Hey, how's it going? So for this module topic, we'll be covering distance between 2 points. And for this module, we'll be utilizing a formula from our formula sheet, which is the distance formula. All right. But as we progress through, you're going to realize that you don't necessarily have to use the distance formula all the time, especially when it's on a coordinate grid. I probably would not use the distance formula if it already has the line or the figure drawn for you. In those situations, you would actually use the Pythagorean theorem. And that's another thing that we're going to notice. The Pythagorean theorem and the distance formula are the exact same thing. All right. So enough about that. Let's go ahead and start utilizing the formula first before we build. So let's go ahead and look at the formula for the distance formula. The distance formula says the square root of everything, x2 minus x1 squared plus y2 minus y1 squared. So that means you subtract your x's and you square them, and then you add, and then you subtract your y's and you square them, and it's all under the square root. All right. So it honestly, it says x2 minus x1, but because you're squaring it, it doesn't matter which one you're subtracting from, long as you subtract your x's from each other, and the same thing for your y's. So for example, let's look here. X2 minus x1, 11 minus 5 gives us 6, right? If I took 5 minus 11, I would get negative 6. Negative 6 times negative 6 is still 30, a positive 36. All right, just like a positive 6 times positive 6 is 36. All right, so it doesn't matter whether you take 11 minus 5 or 5 minus 11, as long as you square it, it's going to give you the same values. So then now, as you can see over here, we took y2 minus y1, 12 minus 20. But notice I don't have the middle steps here, like I did over here in the middle. The reason I say that is because just type this into Desmos. So if I type this into Desmos, you type in square root, and we have 11 minus 5 squared plus 12 minus 20 squared. All right. And once you have it in, it tells you what your answer is. It's 10. All right. But then sometimes it doesn't give you a smooth number like this, and they might want your answer with the radical. If they want that, you would just go ahead and delete the radical, and you know that your answer is the square root of 100. All right. We'll look at an example where it doesn't give you a whole number, it gives you a decimal, and they might ask you for the exact value. So let's look at the next example. If we want to find a distance here between these 2 points, we'll take square root of 4 minus 7 squared and 2 minus a negative 3. Notice that I wrote 2 minus a negative 3 here. And then type all this in one step. All right. So then here you take 4 minus 7 plus 2 minus a negative 3. And you square it, and you get 5.8, right? If you round it to the nearest tenth, the first decimal place. But sometimes they might say, hey, what is the exact answer? Which is not 5.8, because that's the rounded answer. So if they want to find the exact answer, they want to know what is that number under the radical. And if you want to find that, just go click here, delete the radical. So I know my answer is the square root of 34. And you will see here that they give you the same answer. So if they give you the decimal and they say, what's the exact answer? You could just go ahead and delete the radical and say, oh, that's the number underneath it. So that means my exact answer is the square root of that number, the square root of 34. All right, which is the same thing as 5.8. Hence, they're equivalent here. So then now when we look at this next example up here, we took negative 4 minus 18, and then we took 22 minus negative 8. Notice I put minus a negative 8. Sometimes these negatives throws off a little bit. All right, so then from here, you would type all that in. And once you type all that in, if you got square root of 1,384, which is 37.2, you are correct. That's the distance between these two coordinate points. Now, what is the distance between these 2 points? Take the x's, subtract them, and the same thing for the y's. All right, so the square root of negative 13 minus a negative 3 squared plus negative 14 minus 8 squared. And if you type this in and you got square root of 584, which is equal to 24.2, you are correct as well. Now that we spent some time practicing finding the distance between 2 points, utilizing a distance formula, now let's look at it in a different context where it might be best to use the Pythagorean theorem. So now look at the first question. It says, what is the distance of side NM? And yes, we can use the distance formula here by taking 12 minus 5 and then squaring it plus negative 5 minus 2 and then squaring it, all right? But you also could use the Pythagorean theorem. So if I use the Pythagorean theorem and actually drew a right triangle with this side being the hypotenuse, this would give me what 1, 2, 3, 4, 5, 6, 7. That means that side would be 7. And then 1, 2, 3, 4, 5, 6, 7. So that will be a right triangle here with 7, 7. So a squared plus b squared equals c squared. So I took 7 squared plus 7 squared and take the square root of that, and that'll give me my distance here, which is the square root of 98, which is 9.9. All right. So if I want to find the distance of side NO, I could just go ahead and draw a right triangle and say, wait, it's going to be the square root of 1, 2, 3, 1, 2, 3. All right, the square root of 3 squared plus 3 squared. I know that's going to be my final result, as you can see here by utilizing the distance formula, but the distance formula is the Pythagorean theorem. All right. So with that being said, make sure you have all the stuff written down in your notes. And from there, we're going to go ahead and practice. If you have questions, concerns, feel free to let me know.